In this video, I'll show you how to adapt a stock rear diff locker for use in the front axle of a Nissan Patrol. Here is the rear diff with the stock diff locker. In this photo, the lock is disengaged. On the other hand, in this photo, the locker is engaged, which is visible because the locking sleeve has shifted to the left side. The bearing caps have been removed. The diff has been removed from the differential housing. And here is the front diff. Here we can see that the bolts securing the front diff to the axle housing have already been unscrewed. The front differential from the inside. The main differential bearing nut lock. Comparison of the Nissan Patrol diffs that we happen to have on the table. From the right, a 2-spider gear front diff, a 4-spider gear rear diff with a stock locker, and an open 4-spider gear rear diff without a lock. A rear open diff without a locker, a view from the outer side of the ring gear mounting. Here we can see a clear passage through the side gears, which is necessary for the axle shafts in a single bearing system, semi-floating axle, using drum brake. Here is the end of such an rear axle shaft with the spline in a single bearing system. This additional rear axle extension rests against a matching extension on the opposite side. A rear open diff without a locker. One part of the housing with the side gear visible, and the other part of the housing with the spider gears visible. Here we can see a special cross shaft for the spider gears, which provides a clear passage through the side gears. And here are all the parts separated. And here is the diff with the stock locker. In this diff we also have a clear passage through the side gears, therefore it is possible to use a stock locker in a rear axle housing with drum brakes. And here is the 2-pinion front diff. As we can see, the 2-pinion shaft is blocking the opening inside the diff. This simplifies the design of the 2-pinion shaft, and a clear passage through the side gears is not necessary for the front axle shafts, as it is for the rear axle shafts with the disc brake system. Both the front axle shafts and the rear axle shafts with the disc brake system are permanently fixed by the double bearing arrangement. We will have to disassemble this 2-pinion front diff to remove the 2 side gears from it. To do this, we first need to knock out the locking pin that secures the 2-pinion shaft. For this, we need a hard rod with a diameter of 5 mm, 0.2 inches. We simply use drill bits, but in the initial phase of knocking it out, we use a drill bit shortened to about 50 mm, 2 inches. Longer drill bit can easily break. Only in the final stage of knocking out the pin do we use a standard length drill bit. This removal takes place from the ring gear side. Next, after removing the 2-pinion shaft, we rotate the sprockets. After that, we remove the side gears. We should note that both the side gears and the sprockets have their own washers. As we can see here, all the differentials I have presented are of the same width. It is very rare to find a situation where the front and rear differentials are the same size. This occurs in most Nissan Patrol GQ and GU models, where the rear differential is the H233 case. In Nissan Patrol GQ and GU pickups, as well as in some GU station wagon versions, the rear diff is larger and is designated as the H260 case. This larger H260 case no longer fits into the front housing. Since the front diff is the same as the rear diff in the H233 case, we can use the side gears from the front diff instead of the side gears in the rear diff. Because of this, we can keep the original axle shafts. The spline in the rear housing at the diff has 33 teeth. However, the spline in the front housing at the diff has 31 teeth. This is why, to keep the stock axle shafts, we must replace the side gears in the rear diff with the side gears from the front diff. At this point, it is worth looking at the complete front axle shafts and CV joints. In this photo, we have the front axle shaft with the CV joint from a Nissan Patrol GU, and below it the CV joint from a Nissan Patrol GQ. First, the GU CV joint is significantly larger, with a diameter of 103 mm, 4.06 inches, compared to the GQ CV joint, which has a diameter of 96 mm, 3.78 inches. The outer splines of both these CV joints are the same, with 31 teeth each. However, the inner splines are different. The GU CV joint has 28 teeth, while the GQCV joint has 27 teeth. Therefore, this area is the weakest point of this assembly. At this point, it is worth adding that there are aftermarket heavy-duty axle and CV joint kits available, which feature a spline at the diff matching the rear with 33 teeth and an inner CV joint spline with 30 teeth. However, in my opinion, this option is more suitable for race cars using these axles that return home on a trailer. For overlanding vehicles, it is better to stick with a setup based on factory specifications, so in case of a failure, we can perform a field replacement instead of waiting for a delivery of custom parts. By the way, the simplest modification for a GQ front axle is swapping it for a GU axle, which is a bolt-on fit. The GU front axle features larger CV joints, larger knuckles, and in most cases, larger brakes. Why all this discussion about strengthening the axle shafts? It is simply because installing a front diff lock and engaging it will significantly increase the loads on the axle shafts. The ring gear bolts for the rear locking diff are longer because the ring gear flange is thicker than the front ring gear flange. Comparison of the ring gears. On the left we have the front ring gear, and on the right the rear ring gear. The front ring gear does not fit because it does not seat against the rear diff cage flange, as the chamfer on the mating side is too small. On the left we have the rear diff cage with a large radius at the ring gear flange to increase strength. On the right, the front diff cage with a small radius at the ring gear flange. A larger chamfer has been machined on the front ring gear on the left, compared to the stock chamfer on the rear ring gear on the right. Bolting the ring gear to the diff center. The service manual specifies a torque of 78 to 93 Newton meters, 57 to 68 foot-pounds. In one section, while a few pages later, it states 132 to 152 Newton meters, 97 to 112 foot-pounds. I applied a torque of 130 Newton meters, 96 foot-pounds. This is how the front ring gear looks with the rear diff center, compared to the stock ring gear and diff center setup. The diff lock slider removed. Here we can see the diff lock slider's contact area and we can clearly observe the local heat treatment. Bearing removal was difficult. The cage had to be removed to provide a proper grip, and the bearing race was notched slightly to make the process easier. In addition to the ring gear chamfer mentioned earlier, the ring gear bolts nearly interfere with the bearing housing because the ring gear flange is wider. Therefore, small clearances had to be machined into the front diff case, both at the top and the bottom. The extent of the clearance machining in front of the ring gear bolts can also be seen here. Since the pinion gear is not moved at all, setting the gear mesh only requires adjusting the backlash, using a dial indicator and the bearing preload. After the initial tightening of the bearing caps and the adjuster nuts, the bearings were adjusted so that under the initial preload, set by feel, the backlash was within the correct range, between 0.15 mm, 0.0059 inches, and 0.20 mm, 0.0079 inches. In this case, the backlash is set to just over 0.16 mm, 0.0063 inches. When tightening the bearing caps, an axle shaft was used for support to reach 93, 68.6 foot-pounds to 103 Newton meters, 76 foot-pounds. New pinion cage bearings from Koyo, part number 17887/31, were installed. To connect the rear diff lock control in the front axle, the cover must be replaced. Here in the photo, we can see the first test fit of the front diff with the rear lock and the cut-off cover. Diff lock engaged. Diff lock disengaged. And here in the photo, we have the rear diff cover with the lock actuator. Here, we are test fitting the rear diff cover with the lock actuator to the front axle. First, tack welding is performed. Internal view. After installing the front axle in the vehicle, another problem emerged that is often overlooked. the panhard rod interferes with the diff lock cover. To solve this, the front panhard rod will simply need to be straightened. It must be noted that this is not a tube but a solid bar, so heating it with a torch will be necessary. Summary: installing a rear diff lock in the front axle is possible. In the rear locking diff, the side gears must be replaced with the side gears from the front axle to fit the front axle shafts. Larger chamfer should be machined on the front ring gear. Minor clearances must be machined into the diff case. The front axle cover must be replaced with the rear cover featuring the lock actuator. The front panhard rod must be straightened to prevent interference with the cover that houses the lock actuator. In the next video, I will describe how to install brake calipers on the rear axle with a handbrake option.